IoT system architecture is often described as a four-stage process in which data flows from sensors attached to things through a network and eventually onto a corporate data center or the cloud for processing, analysis, and storage. So this is the first stage, stage 1, sensors and actuators. The process starts with sensors and actuators, the connected devices that monitor, in the case of sensors, or control in the case of actuators, something or physical process. Sensors captures data regarding the status of a process or an environmental condition, such as temperature, humidity, chemical composition, fluid levels in a tank, fluid flow in a pipe, or the speed of an assembly line, as well as much more. In some cases, a sensor might detect a condition or event that requires an almost immediate response so that an actuator can perform remediation actions in real time. For example, adjusting the flow rate of a fluid or the movements of an industrial robot. In this situation, very low latency between the sensor and analysis triggered actuator is required. To avoid the delay of a round trip of the data to the server, analysis of data to determine failure, and sending of control to the team. This critical processing is performed in close proximity to the process being monitored or controlled. This edge processing can be performed by a system on module or the SOM device such as a DG Connect Core module and or a DG cellular router with Python. So the next stage is the stage 2, internet gateways and data acquisition systems. A data acquisition systems or the DAS collects raw data from the sensors and converts it from analog into digital format. The DAS then aggregates and formats the data before sending it through an internet gateway via wireless or the ones such as Wi-Fi or cellular, or wired ones for the next stage of processing. At this point, the volume of data is at its maximum. The quantities can be huge, especially for example, in a factory setting where hundreds of sensors may be gathering data simultaneously. For the reason, the data is also filtered and compressed to an optimum size for transmission. So the third stage is the stage 3, pre-processing analytics at the edge. Once the IoT data has been digitized and aggregated, it will need processing to further reduce the data volume before it goes to the data center or cloud. The edge device may perform some analytics as part of the pre-processing. Machine learning can be very helpful at this stage to provide feedback into the system and improve the process on an ongoing basis, without waiting for instructions to come back from the corporate data center or cloud. Processing of this type will generally take place on a device in a location close to where the sensors reside, such as in an on-site wiring closet. So the last stage is the stage 4, in-depth analysis in the cloud or data center. At stage 4 in the process, powerful IT system can be brought to bear to analyze, manage, and securely store the data. This usually takes place in the corporate data center or in the cloud, where data for multiple field sites sensors can be combined to provide a broader picture of the overall IT system and deliver actionable insights to both IT and business managers. A company may have operations in different geographies, and IoT data can be analyzed to identify key trends and patterns or to spot anomalies.